So we're going to start off with chapter 2, so 2-1. And today we're going to be learning about solving equations. Solving equations. So we'll talk about one-step and multi-step equations both. So let's start off with one-step equations. Okay, basically the idea is when it comes to solving equations, so basically we're just isolating the variable and then we are just solving for that. So get that variable by itself and then just go from there. So let me start off with one-step equations. So let's just make it colorful, pick a different color. So let's start off with one step. I'm going to show you two different examples. So I have x plus 4 and it's equal to negative 12. And on the other side, I have 3x is equal to 15. Okay, when it comes to solving, we're isolating the variable. And how do we isolate? So you just have to do its inverse operation. If something is being added to that, so just subtract the number and then isolate. If something is getting multiplied or divided, just do its inverse and then just go from there. If I look at the problem one we have on the left side, what I see is this x has this 4 added to it. How would you get rid of that 4? So I would just do its inverse. So I would take away 4 both sides. This is how this 4 is going to get canceled out. And now just simplify like normal equations. So x is equal to negative 16. And here you go. That's my answer. You can even check if you want it. So if I plug this negative 16 back in here, isn't it negative 16 plus 4 makes negative 12? So it means we did it right. Now let's move on to second example, the one on the right side. I see 3 getting multiplied by x. So we need to isolate this variable. So we need to get rid of this 3. So how do we do that? So now there are two different things you could do. You can divide by the same number, which is 3. You can divide both sides by the same number. That's one thing. Or you can say multiply by the reciprocal. So you can multiply by the reciprocal. So 3 was the reciprocal, 1/3. That could be another way you could get rid of that. So I'm just going to use a different color. So if I multiply by, let's say, 1/3 both sides, it's still going to be the same thing. So I repeat, dividing by the same number. So if you divide by the same number or multiply by the reciprocal of that number. Either ways, it's going to be the same. All right. So pretty much, I'm just going to go by the blue number, which is dividing by 3. So this, I'm just going to cross off this part because you got to do either or. So divide by 3. So finally, x is by itself, and your answer is 5. Here you go. You can even check. So 3 times what makes 15, which is 5. Here you go. So we did it right. Now, this was one-step equation. Now let's move on to multi-step equation. So multi-step equation. Okay, here comes my first example. I have negative 27 added to 6y, 3 parentheses y minus 3. All right, so when you see something like this, the first thing I would do is I would just make this or simplify this equation just to make it look normal. I see parentheses in there, so I really want to get rid of parentheses first. So let's distribute. Some people call that rainbow property or distributive property. Either way, it's fine. So basically distributing this 3 to both of these things inside the parentheses. So let's do that. The rest of the stuff would stay the same. Distribute 3, this becomes 3y. 3 times negative 3 would be negative 9. Next, rest is pretty much combining like terms. So first, I would combine like terms. When I say like terms, it means the terms have same number, or same variable. Or let's say just constant would be like term to its constant. A variable like same variable would be like term to same variable. So like here, I see 6y matches up with 3y. So those two are going to be together. We need to combine. This constant goes with this constant, so I need to combine these together. Okay, so if those like terms are on the opposite side, so if it's on the opposite side, we just do inverse operation. So it means if something is being added on one side, I would subtract both sides to get rid of that number. Okay, so let's look at that part. So first, okay, now here's the thing. You need to keep the variable on one side and rest of the stuff on the other side. Try to keep variable on the left side. It would be easier. So I'm just gonna subtract 3y. Let me just erase these lines because now it feels like it's kind of confusing. Okay, so I would take away 3y both sides, and then I would move the constants on the other side. So I would add 27 both sides. So I would leave variables on the left side and numbers on the other side. So this 3y is going to get canceled out. So I have 3y left on the left side. And on the right side, what I have is it's going to be 18. And finally, this one looks like normal equation. So pretty much you need to get rid of this 3. So I would divide by 3 both sides. And finally, my answer is going to be 6. And if you want to check your answer at the end, you could do that. So just plug in this number for y in the equation, and that's how you can check. If both sides are equal, it means this answer is correct. Okay, I have one more example. So let me show you that. So let's say I have 12 minus 3 parentheses 2x plus 1. It's equal to 7x minus 3, 7 plus x. If you look at the first time, it feels like it's the scariest problem I've ever seen. So what I would do, I would actually make it look like normal first. I'll do distributive property first. So if there's any parentheses in the problem, I would distribute it first. So I see parentheses in there. So both sides, I would distribute that first. 12 minus, distribute this negative. It's better if you carry the negative over, so this becomes negative 6. Distribute this negative to positive 1, negative 3, 7x. Same on this side, distribute negative 3 to both of these, becomes negative 21. Oh, there's no x, my bad. And then there would be 3x. Okay, now what I see multiple like terms here. Now here's a common mistake what a lot of people do. So when it comes to like terms, if you have like terms on the same side, we just follow the signs. So if you have it on the same side, I'm going to write that down for you. We just follow the signs. But if you have like terms on two different sides, like both on opposite side, then we always do the inverse operation there. So I see 12 and negative 3 on the same side. I'm just going to follow the sign. So 12 minus 3 becomes 9. The 6x would stay the same. All right. Do we see any like terms on the other side? Yep, I see 7x and 3x on the same side. Again, I would just follow the signs. 7x minus 3x is 4x and 21. Now, since I see like terms on the opposite side, this is where you need to do inverse operation. So let's combine like terms. Try to keep variables on the left side. So I would take away 4x both sides. So this becomes negative 10x, and there's a 9 still there. Now I would move this 9 over to other side. So I would take away 9, so subtract 9 both sides. Negative 10x, negative 30, almost there, one more step. So this negative 10 is getting multiplied, so I will get rid of that by dividing by negative 10 or multiplying by the reciprocal. So either or, it's fine. X is equal. Another example here. So it's a flower carpet that's in Belgium. So what we are trying to do here is, like, if you look at closely, let me try to figure out the shape first. That's what the exact shape is. So this side is x long and this side is 3 times bigger than this side. And basically what we are trying to do is we are trying to find both side lengths. And let's see what we know in this problem. So we know the perimeter is 200 meters. So basically when I add all four sides, this has to be equal to 200. So how would you solve for the missing variable? So what I'll try doing is, because I know if this side is x, this would also be x. If this is 3x, again, this would also be 3x. So I would just set up an equation. So if I add all three sides, Or if I just add length plus width and times it by 2, it's going to be the same thing. But anyways, I'll just write it out like this: x added to the other x side across, 3x added to other 3x, and let's just set it equal to 200. Now rest is pretty simple problem, so I'll just add all the variable or like terms and then solve for x. X added to x is 2x. 3x added to another 3x would be 6x, and it's equal to 200. Still, I can keep going, combine like terms, and I have 8x is equal to 200. Divide by 8 both sides. Gosh, you can't see this color. Let me pick a different one. Let's pick something lighter than that. How about this? I hope this would work. Yeah. Divide both sides by 8, and finally, it's going to be 25. 25 just going to be for this side. What about the other side? So that's going to be 3 times this, which is going to be equal to 75. So that's how we find those missing side lengths. So I have one more example, so let's talk about that. I need to finish this. Okay, let's move on. These type of problems are called like kind of problems with unique solutions. Unique solutions, like you would not see kind of exact solutions like the previous problems we did it here in this section. So I'm going to show you 2 problems like side by side. Like I have 11 plus 3x minus 7 is equal to 6x. 5 minus 3x, and I'm going to write the other one on the side here. So 6x, 5, 2x, it's equal to 4 plus 4x plus 1. Okay, so let's look at the one on the left side. So first thing, I'll try combining like terms. Again, I repeat, if you see those like terms on the same side, you could literally follow the signs, but if it's on the opposite side, we do inverse operation. So I see 11 and 7, both on the same side. I'm just going to follow the sign. 11 minus 7 is, it's going to be 4 plus 3x, and on the other side, 6x minus 3x would be 3x plus 5. Now, if you try combining like terms, so let's try combining x's. If I take away 3x both sides, pretty much variable is going to get canceled out. So what I have left is 4 is equal to 5. So anytime the x's or any variable get canceled out, so pretty much your answer would be based off this leftover equation. If it's a true statement at the end, 4 is not equal to 5. So it means it's a false statement, so it means there would be no solution of this problem. So none of the value for x would work for this equation. So there would be no solution. So I repeat, if the statement at the end is false, there would be no solution for that problem. Okay, so the one on the right side, same thing. So let's combine these like terms first. So that would be 4x plus 5. On the other side, 4x plus 5. Eventually, if I try combining x's, yeah, so x is going to get canceled out again. So what I have left is 5 is equal to 5, which is true. So if any time you ended up getting true statement, there's no x or no variable left in the equation, and the statement, the leftover statement at the end is true, then there would be many solution for this problem. So no matter what number you plug in for this x in this equation, it would work. So every single number, all real numbers would work for this type of problem. So there's going to be many solutions. So I repeat, if it's a false statement, there would be no solution. If it's a true statement at the end, there will be many solutions for this problem.